Okay, so I'm going to talk about the 6.7 with you guys today, and basically it's the coordinate version of what we've been doing in the parallelogram and the quadrilateral chapter. Okay, so if you look at this first picture right here, you probably recognize at least this part because this is what we did in the test number, what was it, 10, right before the semester break, and we used the parallelograms, rectangles, rhombuses, and squares, and the properties of those figures to solve problems dealing with parallelograms. Now we're going to do trapezoids, isosceles trapezoids, and kites. Okay, we're going to add all of them together, however, for the 6.7, because basically we're going to graph these quadrilaterals, and then we're going to use their properties and these three formulas, distance formula, midpoint formula, and slope formula, to determine what quadrilateral we have. Okay, so go ahead and fill in this chart. Okay, so if you remember, I just kind of clipped some of the properties from the different, because I know it's been a little while since we've done the parallelogram, so I just wanted to kind of remind you of the different properties. And we're going to go through 22. Now, you don't have 22 on your paper because 22 is an even and you only have odds. So you're watching this one, right, to see how it works. You can either do it with me on a 10 by 10 or you can just watch so that you can see the process, okay? The first thing I would do is to go ahead and choose which one you think it's going to be based on its appearance, okay? So if I graph this right here, based on its appearance, what do you think it's going to be? It's probably going to be a parallelogram, right? It looks like it has two pairs of parallel sides, and it doesn't look like they're congruent, does it? Okay. However, 6.7 is all about not what you know, but what you can prove or justify, right? So we've got to use mathematics to prove. So these are the things that we would have to prove in order to say it's a parallelogram. So what would we use to prove that opposite sides are parallel? Which one of the formulas would we use? Slope, distance, or midpoint? Slope. Okay, so what was the slope formula? Y2 over x2 minus x1. Exactly. Okay, so now the good news is this one actually has two horizontal lines. So do we actually need to do the slope for those? No, we know that the slope of this one's going to be 0 and the slope of this one's going to be 0. So I can already say, before I do any of the mathematics at all, that VU is parallel to what? ST. Okay? So let's go ahead, though, and do the slope for VS and UT. Okay? So V is negative 2, 2. So I'm going to say that's 2 and negative 1. And then S is what? 0, 0. Okay? So the slope is going to end up being 2 over negative 1, which is what? Negative 2. Okay? And that was the slope for VS. Okay? So let's go ahead and do the slope for UT. Okay? So U is going to be 2, 3. And T is going to be minus 0, minus 4. Looks like we're going to get 2 over negative 1, which is negative 2. Okay, so what do we think? Same slope? Yeah. Okay, so I can say then I have mathematically justified that VS is what? Parallel to UT. Okay, Then let's look at this one. Opposite sides are congruent. Well, again, because VU and ST are horizontal, I can just count them off, can't I? To see that they have the same distance. So let's do this. We'll say that VU is going to be equal to 1, 2, 3, 4. So that's going to be 4 units, right? And ST is going to be equal to 1, 2, 3, 4, right? So are VU and ST congruent? Yes, they are. So I can say, okay, then VU is congruent to ST. Now, I need to say, are VS and UT congruent? Okay, well, for those, I'm going to have to use what? The distance formula, right? So let's find the distance for VS. Remember the distance formula? Okay, so what's the x coordinate for V? -1. And what's the x coordinate for S? 0 squared. Plus, what's the y coordinate for V? Okay, and what is the y coordinate for S? Okay, 0. So if I plug those in, I'll get -1 squared plus 2 squared. That's going to give me the square root of 5. Yeah? So we got to do the same thing for UT. Now, what do you think we're going to find out for UT? That they're probably going to be the square root of 5 also, right? It's probably going to be congruent. All right. So what's the x coordinate for U? And the x coordinate for T? Okay, and what is the y coordinate for U? And the y coordinate for T? Okay, so it looks like I'm going to get -1 squared plus 2 squared again. And that's going to give me what? Square root of 5. So are VS and UT congruent? Yes. Okay, so I can say that VS is congruent to UT. All right, so far with the parallelogram, I've proven 2 of the 3 things that I need to prove, right? Now, that's enough to prove that it's a parallelogram, but because we're doing this as an example, let's go ahead and use the midpoint to prove that the diagonals bisect, yes? All right, what's the midpoint formula? x1 plus x2 over 2, yeah? y1 plus y2 over 2. Remember that one? If the diagonals VT and SU are bisectors, or they bisect each other, that means that they'll both have the same midpoint, right? So let's see if they indeed do have the same midpoint. Ready? So let's look at V and T. So what are the x's for V and T? -1 plus 4 over 2. And then what are the y's? 2 plus 0 over 2. That's going to give us what for a midpoint? 3 over 2 plus and what? 1. Okay, so now let's see if we get the same midpoint for S and U, shall we? What are the x coordinates for S and U? 0 plus 3 over 2. And then what are the y coordinates for S and U? 0 plus what? 2 over 2. Okay, that'll also give us a midpoint of what? 3 over 2 and what? 1. So do they have the same midpoint? Yes, they do. So are they bisectors? Yes. So we have proven that this figure is a parallelogram. Okay. However, we need to also prove that it is not a rhombus. How can we prove that this is not a rhombus? How do we know it's not a rhombus? All sides are not congruent, right? Okay? So, when you do all this math, which I'll be looking for to justify, right, what you're saying, you will conclude with the figure, and what were the letters? UVST. UVST is what? A parallelogram. Because, why? Because opposite sides are what? Parallel and what? Congruent. And diagonals what? Bisect. Yes? That's how you do it.